You wake up, you slept, you didn't drink last night, you have no major illness on record, and yet you're exhausted. Not tired, not sleepy, exhausted. Before the day has even started, and no amount of coffee fixes it. You push through the morning, you crash by 2 in the afternoon, and somewhere in the back of your mind, a voice says, "What's wrong with me?" Here's what I need you to hear today. Nothing is wrong with you. Your cells are not broken. They are not failing. They are doing something far more intelligent than that. They are protecting you. And until you understand that distinction, you will keep fighting your biology instead of working with it. I'm Dr. Max, and today we are decoding mitochondrial health and the bioenergetics of fatigue from a biological and practical perspective. We're going to go deep into the cellular machinery behind zero energy. We're going to identify the modern disruptors that are silently stalling your biology, and then I'm gonna give you a precise protocol driven reset. Subscribe if this is your first episode, and let's get into the science. Alright, the part 1. The paradigm shift. Your mitochondria are not batteries. Every biology textbook tells you the same thing. Mitochondria are the powerhouses of the cells. They generate ATP, adenosines, triphosphate, your cellular energy currency, and they keep everything running. That model is correct, but it is incomplete, and the missing piece explains everything. Dr. Robert Navio at the University of California, San Diego has spent decades researching what he calls the cell danger response, the CDR. And his work reveals something that fundamentally reframes how we understand fatigue. Mitochondria are not passive batteries. They are intelligent environmental sensors, and they operate in one of two mutually exclusive states. State 1, energy mode. The mitochondria are producing ATP at full capacity. You feel vital, motivated, clear-headed. Your cells are open for business. State 2, defense mode. The mitochondria have detected a threat: chronic stress, environmental toxins, nutrient deficiencies, inflammatory signals, and they have made a deliberate decision. They have tripped the circuit breaker. They have throttled energy production to protect the cell from further damage. Think of it like a city during a blackout drill. The power grid doesn't fail. The city chooses to go dark, to conserve, to protect the infrastructure from a threat it has identified. Your fatigue is that blackout drill. It is not a malfunction. It is a biological defense decision. And this reframe changes everything. Because if fatigue is a defense response, not a failure, then the solution is not more stimulants. The solution is to signal safety back to the cell. Now let's talk about the part 2. Inside the engine, why the ATP factory stalls. Now let's go inside the mitochondria, because to fix the problem, you need to understand exactly where the machinery breaks down. Your mitochondria generate ATP through a process called the electron transport chain, the ETC. Picture a factory assembly line with 4 production stations called complexes. Electrons flow through each station in sequence, and at the end of the line, ATP is manufactured. That ATP powers every thought, every heartbeat, every movement you make. In a healthy cell, this line runs smoothly. But in dysfunctional cell, electrons leak out, primarily at complex 1 and complex 3. Those escaped electrons don't just disappear. They react with oxygen and from superoxide, a highly reactive molecule. Think of it as cellular rust, oxidative damage that accumulates inside the mitochondrial membrane itself. The body detects this rust and it responds by throttling the line further. Less production, less damage, but also less energy. Now, there is a second mechanism I need you to understand. It is called NAD bankruptcy. Nicotinamide adenine dinucleotide is the molecular truck that carries electrons through the energy assembly line. Think of NAD as an empty truck ready to load cargo, and NADH as a full truck that has delivered its load. For the factory to keep running, you need a constant supply of empty trucks, NAD. But here's the problem. A diet chronically high in fructose and industrial seed oils creates a massive surplus of NADH. Full trucks everywhere with nowhere to go. The ratio tips. NAD is depleted, and when the trucks run out, the assembly line stops. Chronic fatigue in many patients is not a mystery. It is a state of NAD bankruptcy. The factory has the workers. It has the the raw materials. It simply ran out of trucks. And there is one more mechanism: cardiolipin collapse. Cardiolipin is a unique phospholipid, a structural fat that forms the inner membrane of the mitochondria. Think of it as the specialized glue that holds the entire energy complex in its correct three-dimensional shape. For cardiolipin to function, it requires stable, saturated fatty acids in its structure. When you chronically consume industrial seed oils, soybean, corn, canola, sunflower, their primary fatty acid, linoleic acid, gets incorporated directly into cardiolipin. These are unstable fats. They oxidize easily. They become, in effect, rotten glue. The energy complexes begin to fall apart, and the assembly line physically disintegrates. You cannot produce energy from a factory whose walls are dissolving. Alright, if you're just joining us or you lost the thread, here's the core takeaway so far. Fatigue is not a failure. It is your mitochondria entering defense mode. A protective shutdown triggered by cellular threats. Inside the mitochondria, three mechanisms drive this shutdown. Electron leakage causing oxidative rust, NAD depletion jamming the entire energy assembly line, and cardiolipin collapses from seed oil consumption physically dismantling the energy complexes. These aren't vague concepts. They are precise, reversible mechanisms, and we are going to address each one in the protocols. Now, let's talk about part 3. The modern disruptors, what is signaling danger to your cells. Your mitochondria evolved over billions of years in a specific environment. Sunlight, darkness, whole foods, physical movement, periodic fasting. These were the signals that kept the cellular environment set to safe. The modern world has replaced almost every one of those signals with something different. Disruptor 1, circadian mismatch and the destruction of melatonin. Your mitochondria have internal clocks. Circadian rhythms synchronized to the light-dark cycle. Artificial blue light at night from screens and LED lighting suppresses melatonin production in the pineal gland. And here's the part most people don't know. Melatonin is not just a sleep hormone. It is the most potent mitochondrial antioxidant your body produces. Its primary job overnight is to enter your mitochondria and neutralize the reactive oxygen species, the cellular rust that accumulated during the day. Think of melatonin as the overnight janitorial crew of your energy factory. No melatonin, no cleanup. You wake up to a factory full of yesterday's waste. That is morning grogginess that no amount of caffeine resolves. Disruptor 2, the liver-mitochondria axis. This is very central to everything we discussed on this show. Your liver contains up to 2,000 mitochondria per cell, more than almost any other tissue in the body. It is the most mitochondrial dense organ you have because the liver's metabolic workload is extraordinary. When the liver accumulates fat in the condition we called metabolic associated steatotic liver disease, those 2,000 mitochondria per cell begin to dysfunction. The liver's energy processing becomes congested. And because the liver is the metabolic hub of the entire body, that congestion creates a systemic energy backup. The signal propagates outward, brain fog, full body fatigue, and motivation collapse. Honestly, these are not primary brain problems. In many cases, they are downstream expressions of a liver that has run out of mitochondrial capacity. In my clinical observations, patients who present with unexplained chronic fatigue, who have had their thyroid checked, their iron checked, their B12 checked, and being told everything is normal, very frequently have a fatty liver finding on an ultrasound. The connection is not coincidental. It is mechanistic. Disruptor 3, glycation. When blood sugar remains chronically elevated, driven by a high carbohydrate or high fructose diet, excess glucose molecules attach non-enzymatically to proteins and fat throughout the body. This process is called glycation, and the resulting compounds are called advanced glycation end products. Think of glycation like caramel hardening on a saucepan. The proteins become stiff, non-functional, and when advanced glycation glycation end products accumulate on mitochondrial membranes on the very lipid bilayer that houses the electron transport chain. The membrane loses its fluidity, its ability to transport fuel, its capacity to function as a dynamic, responsive energy platforms. Sticky membranes, stiff machinery, and throttlet output. Part 4. The Neuromotivation Connection. I want to spend a moment on something that I find rarely discussed in the fatigue literature, and it explains why mitochondrial dysfunction doesn't just make you physically tired, it makes you emotionally flat. Your brain consumes approximately 20% of your total ATP output. It is the single most energy demanding organ in the body relative to its size. And within the brain, the dopaminergic neurons, the cells responsible for motivation, reward, anticipation, and executive function, are particularly dependent on mitochondrial energy. Here's the mechanism. Dopamine packaging requires ATP. The process of synthesizing dopamine, loading it into vesicles, and releasing it across the synapse is energetically expensive. When mitochondrial output drops, dopamine packaging slows. The result is not just fatigue, it is motivational collapse, the inability to start tasks, the emotional flatness, the feeling that nothing seems worth doing. These are not psychological failures. They are the downstream consequence of a bioenergetic deficit in the neurons that drive motivation. You're not lazy, you are running on an empty dopamine pipeline because your mitochondria cannot afford the fuel to fill it. Let's anchor everything so far. Your mitochondria are the defense mode triggered by 3 primary modern disruptors. Destruction of melatonin by artificial light, a congested fatty liver creating a systemic energy backup, and glycation stiffening the mitochondrial membranes themselves. And the consequence reaches all the way up to your brain, collapsing the dopamine system and stripping you of motivation. This is one unified biological cascade. Now, let's move from the why to the how. The root cause analysis. The root cause of mitochondrial fatigue is not aging and it is not a supplement deficiency. The root cause is a bioenergetic mismatch. We have built a civilization that sends continuous danger signals to our cells through the food we eat, the light we expose ourselves to at night, the chronic psychological stress we carry, and then we are confused when the cells respond to those danger signals by entering defense mode. The primary hormonal driver is the same one we return to on this show consistently: chronic hyperinsulinemia. Elevated insulin driven by fructose, refined carbohydrates, and ultra-processed foods directly drives hepatic fat accumulation, NAD depletion, glycation, and mitochondrial membrane instability. Every mechanism we've discussed today has an insulin connection. Fix the insulin environment, remove the danger signals, and the mitochondria will come back online. Now, let's talk about the protocols. Protocol number 1. Trigger mitophagy through intermittent fasting. Mitophagy is your cell's quality control process, the mechanism by which damaged, dysfunctional mitochondria are identified, broken down, and recycled. Think of it as the cell eating its own broken machinery to clear space for new equipment. Mitophagy is activated when insulin drops and autophagy is engaged, which occurs reliably during a fasting window of 16 to 18 hours. This is the foundational protocol. Without clearing the damaged mitochondria, adding nutrients is like renovating a building without first removing the rubble. Protocol number 2. Stimulate mitochondrial biogenesis through cold and zone 2 movement. Once damaged mitochondria are cleared, the goal is to build new, functional ones. The master switch for mitochondrial biogenesis is a protein called PGC1-alpha. Think of it as the construction foreman who orders new mitochondria to be built. 2 stimuli activate PGC1-alpha most reliably: cold exposure, cold showers, cold immersion, which sends a powerful safety through challenge signal to the cell, and zone 2, cardiovascular exercise, a sustained moderate intensity effort where you can still hold a conversation. 20 to 30 minutes, 4 times per week. This is not performance training. This is cellular infrastructure investment. Alright, protocol number 3, red light therapy for cytochrome C oxidase activation. Red light at the 660 nanometer wavelengths is absorbed directly by cytochrome C oxidase, the terminal enzyme of the electron transport chain, the final station in your energy assembly line. Red light reduces the viscosity of the structured water inside the mitochondria, allowing the ATP-producing motor called ATP synthase to spin with less resistance and greater efficiency. Think of it as lubricating the motor. 10 to 20 minutes of red light exposure to the torso in the morning, ideally combined with natural morning sunlight for circadian anchoring. Protocol number 4, the nutrient spark plug stack. 4 compounds are non-negotiable for mitochondrial function. Coenzyme Q10 in its ubiquinol form, the active reduced form, is the essential electron carrier between complex 2 and complex 3, and without it, the assembly line cannot run. The other one is PQQ, pyrroloquinoline quinone, is unique in that it directly stimulates the spontaneous growth of new mitochondria independently of exercise. The other one is magnesium. Every ATP molecule in the human body must be bound to a magnesium ion to be biologically active. There is no such thing as functional ATP without magnesium. Virtually every cellular energy transaction requires it. And finally, thiamine, B1, and riboflavin, B2, the critical cofactors for glucose metabolism and ETC complex stability. Deficiency in either creates a specific bottleneck in energy production that no other supplement can compensate for. Protocol number 5, eliminate the 3 primary danger signals. Remove industrial seed oils from your diet entirely. They are directly incorporated into cardiolipin and structurally destabilize your mitochondrial membranes. Eliminate blue light exposure after sunset. Use blue light blocking glasses, warm lighting, and screen curfews to restore the melatonin-based overnight cleanup system and reduce the fructose load aggressively. Fructose is the primary driver of hepatic NAD depletion and the fatty liver congestion that creates systemic energy backup. These are not lifestyle preferences, and they are the removal active cellular threats. Alright, let me give you a quick summary. Here's the complete picture. Zero energy is not a character flaw, it is not aging, it is a bioenergetic mismatch. Your mitochondria locked in defense mode by a modern environment that continuously signals danger to your cells. The reversal pathway is precise. Clear the damaged mitochondria through fasting, build new ones through cold and movement, activate the energy complexes directly through red light and targeted nutrients, and eliminate the 3 dangerous signals that triggered the shutdown in the first place. Your cells have not given up on you. They are waiting for the signal that is safe to come back online. Zero energy is not a failure of willpower. It is not an inevitable consequence of age. It is a bioenergetic mismatch, a civilization that signals danger 24 hours a day to cells that were designed for safety, sunlight, and seasonal rhythms. The protocol exists, the mechanisms are understood, and your mitochondria, given the right environment, are fully capable of rebuilding. I'm Dr. Max, and I'll see you in the next episode. Stay healthy, and thanks for listening.